I want to make just a couple more comments about this example that we just worked through where we found the general solution to a system. So I have the original problem at the top, and then at the bottom is our solution in the red box without the matrices in between. And what I want to do is relate this a little bit to that theorem 2 that we mentioned in class, but I didn't really go through all the details of it. So back to theorem 2. A linear system is consistent if and only if the rightmost column of the augmented matrix is not a pivot column. What does that mean? Well, in this example we just worked through, the rightmost column, notice at the end, was not a pivot column. The pivot columns were 1, 3, and 6. So because that was not a pivot column, we know there has to be a solution or solutions to this system. If it were a pivot column, that last row would be of the form all zeros and a non-zero number. That's really the only way that last column could be a pivot column, so that if it's all zeros and a non-zero number, the system is actually inconsistent and there's no solution. So we've seen an example of that before. So that's the first statement in theorem 2. It tells us something about when there is no solution. It also tells us something about when there's not a solution, right? Or when there is are solutions or when there's not solutions. For consistent systems, now that's when there is a solution, systems are consistent. There are two possibilities, right? There could be a unique solution, or there could be infinitely many solutions. In this example, there are infinitely many solutions, and what the theorem says is that's because there are free variables. That means we've got some non-pivot columns in our reduced matrix. Don't count the last one because that doesn't correspond to any of the variables. So our theorem says that there's got to be at least one free variable. You can only get a free variable if one of the columns corresponding to a variable is not a pivot column. If all the columns corresponding to variables, so not the last, if all the columns corresponding to variables are pivot columns, then there is exactly one solution. And we saw that in an earlier example where all the columns before the last were pivot columns. The last column was not a pivot column, and there was precisely one solution to the system. So I hope that helps clarify a little bit what this theorem 2 from the textbook is referring to.